All right, we're going to talk about calculating the transformer load. And what this gets down to is that sometimes somebody that has a little shop has previously expanded their shop and bought new equipment, and then they want to expand again, and suddenly they want to use a bunch of old equipment that they've had before. And they'll drag it into a room and say, can you hook this stuff up? And sometimes it's the wrong voltage for the area, and you're going to have to put in a transformer just for this equipment, because let's say the new equipment that he bought and the new building that he moved into was 480, but the building he'd moved from was 240 or 120, 208, something like that. And so he's got this old equipment he wants, so can I use this stuff? Well, the answer is, with a lot of code question, is maybe. It depends. It might not be economical to do that because you're going to have to buy a transformer to do this. So to calculate what you're going to do, or what you're going to need to do if you do decide to use the transformer and put in this situation, then you need to be able to calculate what you're going to need to use to do this. Back to writing that material list, right? Okay, so let's look at a motor block we're going to put in. And we're going to say that, let me move the recording block. We have just 4 motors in this thing, and we can see their horsepower, right? So let's look up in 430, 250, these are 3-phase. They're 208 3-phase motors. So we're going to look up their full load amperage because we need to know, right? And we're going to do it just like we would any other calculation. Okay. So my 1 horsepower, and this is 208, I think. Yep, 208. And you see a column just for 208. We have one that's a 1 horsepower. Let's see, 208 is 4.6. We have a 10 horsepower. $30.8. How many people thought that should have been 46 amps? I do. And then 50 horsepower, pretty big motor, especially on 208, 143 amps. And then 100 horsepower at 273. Okay, so our 1 horsepower, the FLA, is 4.6 amps. Our 10 horsepower is 30.8. Our 50 horsepower is 143. And our 100 horsepower is 273. Now, if we were doing our wire calculations and everything else, we would go up and we would take 125% of each one of those, and we would find our motor branch circuit ampacity. But for this case, we don't need to do that. We do need to do this for the biggest motor, because you know that if we're going to find our minimum ampacity of our supply circuit, we need to take 125% of our biggest motor. So we're going to have 125% times 273. We wind up with 341.25. And then we're going to add the other full load ampacities to that. And so we're going to do that now, plus 143, plus 30.8, and plus 4.6. And so our grand total is 506, whoops, I'm sorry, 519, not 516. All right. Now, that means that we're going to have some conductors coming in here, and we need to find the size of those wires. So let's go to 31016. Now, in this particular case, we have a delta Y transformer feeding this load, and we've got an additional single phase panel, or actually it's a three-phase panel, that's pulling 40 amps. Okay, so we're going to say that our total load on our transformer is going to be about 560 amps. Everybody agree with that? Now we've said that this thing is a delta Y, right? And we know that this thing is a step-down transformer from 480, right? 480, so it's 270, it's 480, 480 because it's a delta, and it's stepping it down to 120, 208. So 208 is our phase voltage, our line voltage, and 480 is our input line voltage. So let's take a look at what's going on here in the actual windings themselves. And we've said this is a delta. And this is a Y. Because we need to look at what happens in the phase, right? Now let's just say that it's a 2-to-1 step down, just for simplicity, right? But if this is 480 on the top, what is the phase voltage? 480. Okay? That's the incoming voltage, remember. Okay? Now, we've got 120, 208. So it's 208 across here, but it's 120 here, right? It's 120 on the phase. So we're looking at phase to phase, 480 to 120. That's not a 2-to-1, is it? It's a 4-to-1. So this is an error, which is fine. Okay, so it's a 4-to-1 step down, right? So let's look at this, and our line current on our Y is 560 amps. Is that correct? Okay. If that's true, what is my phase load? What is my phase load? If in a Y, what is equal? Current. Current. So my current across a secondary winding is 560 amps. Right? Everybody agree with that? Okay. If it's a 4-to-1 step down, 120 times 560 has got to be equal to 460 times the current in here. So it's going to be 1/4 of the current. Is that correct? So I'm going to have 140 amps here. And we wanted to do that to find out what supply wires we're going to have to bring to this thing, because from the distribution panel to wherever we're working, where we're bringing this power, we're going to take a home run back to the distribution panel, right? And we need to know what size wires and conduit we're going to have to bring for that. So now we can see that we're going to have to carry 140 amps, right? And so we're probably going to add 25% to that ampacity so that we don't overload the wire. So we know that we want conductors that will carry 175 amps. Can everybody see that? All right. Now, pretty simple operation, right? So everybody can see that if we put in a transformer, and let's say that the owner is wanting to add this sub panel, this distribution panel, step down transformer, and these new motors. And we can say, well, you know what? You might be saving some money to not have this supply system if you can live without the 12208 panel. Right? If they're needing the 12208, they're expanding and they're adding a little office, and this 12208 is stepping down for that. But you might be able to get a smaller, well, the same size transformer for that part, but you might be able to use a much smaller transformer if you're not supplying your whole shop, these motors over here, with that transformer. And so it might be a savings in money to step down just for a single phase panel, the panel that will supply single phase loads, even though it's a three-phase panel. What we need to pick up out of this for the moment is that we would have to have 175 amp wire, however many feet going back for this load. Now that's a good thing in a way, because instead of having 900 kcmil on the conduit going all the way back, this is much smaller. And that might play into which way is cheapest to do this. Because one of the things you're going to have to do is you have to watch the customer's money like it was your own, right? So you have to calculate, well, which way is the cheapest way to do this job and still create an efficient system? So one of the things you need to do sometimes is you need to, well, can I avoid using this transformer, or can I avoid using such a big transformer? And what is that going to be cost difference in wire size and conduit? And that comes down to estimating. And when you go out on a job as an owner or a foreman, a lot of times you have to estimate, and that's where this is coming from. Okay, so I'm going to stop this now, and we're going to start on another little talk about this same kind of thing. But that's, we've found, now what size, now transformers are sized in kVA, right? How much power are we sending through this transformer? 560 amps at what? What is our three-phase power? What's the formula for three-phase power? Well, if we stay in phase, we can just multiply times 3, which I like to do, as you know. So we have, what is it right here? 120 times 560 times 3 would do it, right? Let's do that real quick. 120 times 560 times 3. 20,000, I'm sorry, 201,600 VA. So it's 202 kVA. All right. Is there a 202 kVA transformer? No, there's 175 and there's 225. And you have to know what sizes you can look up that you can use. So this is going to step us up to a 225 kVA transformer. And I believe that's the size, but I'm not dead positive. Now, have I left anything else out on transformer size? So we know this would be about at least 202 kVA, right? And we know that we would have 175 amp wires coming to it, and we would have 900 kcml wires going to the auxiliary gutter from the transformer distribution panel. Not the main distribution panel, but the transformer distribution panel. Okay, let's stop there. Oops.